We've already talked about how to make our code in Python have good style in the micro sense. That is, how to make good variable names, how to use proper spacing and commenting. But now we want to dive a little bit deeper and look at code structure in the macro sense. That is, sometimes, actually frequently, you can write code that is correct in the sense that it produces the right output, and yet in my view is unacceptable. How is that possible? Well, just like you can write an essay in English that sort of gets the point across but is a mess, and your instructor might give your essay back to you and say, well, you got the dates right in this report, but you need to rewrite it. In the same way, it is possible to have code that does the right thing and is a mess. It is unmaintainable, it is unreadable, because your code is not structured well. It is not something that humans can read and make sense of, even though the computer might. So we're going to look at this issue by addressing the following problem. If you have a string which is a sequence of characters that just has two kinds of characters, stars and dashes, I'd like to count how many stars and how many dashes are in the string, and I want to know what is the longest sequence of stars, that is the maximum length of stars in a row, and the longest sequence of dashes. It's not that hard, but it's not actually simple either. So when we have a problem that isn't that easy, what's the best way to get started? Draw a picture. So let's go do that.
So here's our string. We've represented it with squares and dashes just because it's hard to draw an asterisk or a star. And I've drawn the indexes into the string, 0 through 7, for this example. So let's start by thinking about how we as humans would solve this problem. Well, we're clearly going to have to iterate over the characters in the string, so we're going to have some kind of loop that goes through it, and we're going to have to keep track of certain kinds of things. So if we were doing this task ourselves, what would we keep track of? Well, it certainly seems obvious that we might keep track of the total number or the count of squares and dashes. So maybe we'll just say square count and dash count. And so as we go through the string, as we iterate over the characters, we can just add on to this. They might start off with values of 0, and then when we get to the first one, we'll see that's a square, so we'll add 1 to that. We get another square, add 1 to that, so now it's 2. We get a dash, add 1 to that, and so on. And so we can count the squares and dashes. That part is easy. The trickier part is, how do we count the maximum length? Well, it seems like similarly we're going to have something like a variable for the max square and the max dash. And these again might start off at 0. And so what happens? Well, we start off with squares. So we have a max of square that gets added by 1, so it turns into 1. We get another one, so we add 1 and it turns into 2. And now we hit a dash. So something has changed, right? We have to know that we are now looking at dashes rather than looking at squares. We can start to increment our dash for a while, so we can go 1, 2, 3 as we get to our third dash. Then we hit a square again. And the key thing is, when we go back to square, even though we're going to keep on incrementing our counts, our maximum square count doesn't get incremented, right? In fact, the maximum square count is still 2, but we might start another count for the current run. Yeah, that's right. So somehow we have to keep some sense of the current character, so we know which one we're counting, and we're going to have to know the current run length. So maybe we're going to have a variable for the run length for squares and the run length for dashes. You're starting to see that even as a human, to do this, it's not that easy. There's a lot of things to keep track of. But I think this is getting close. So if we have the current character, say right now it's a square, And suppose our current run length is 0 for everything because we're, maybe in some initial state. Then when we look at a square, we can say, well, we're current character is a square. We just saw a square, so our run length of squares just incremented. Now, if we see another square, our run length of squares would increment again. And the key thing that we have to observe is that when the current character changes, say maybe now we see a dash, so it changes from a square to a dash. At this point, this current run has completed. It can't get any longer. So maybe this is a good time to check the maximum run length for squares compared to the current run length and change the maximum run length to the current run length if this is in fact the new maximum. Then set the current run length to 0, maybe for both of them, and now we can start counting our dashes. And that's the basic idea. Let's see what this might look like in code.
All right, well, I've just put in some basic code here that reflects the design that we just had. Here's an initial string. Here's our function, and here are the variables that I've just defined to match what I was thinking about when we were sketching. The total number of stars, dashes, the maximum sequence of stars and dashes, maybe I'll move this down. So the current run length of stars and dashes and what the previous letter was. We need to know what the previous letter is so we can compare it against the current one to see if it's changed. And here's our loop. We're going to loop for every letter in the string. I just put pass here because we haven't written this yet. And then I just have some output to print some, the result, call process string. If we run it right now, it prints some nice stuff, but of course it says everything is 0 because we haven't actually done any processing. But that's where we are to start. So let's start by processing the stars. Remember we said, if it's going to be a star, then we'll compare that. So we'll say if the letter is a star, then we can do some of the things we talked about. We should discount the fact that we have a star, so we can add on 1 to our star count, because we definitely know we have a star. And now let's check to see if we are on a sequence of stars or if it has changed. So if the current letter is the same as the previous letter, which means in this case it's a star, because we're looking at stars right now, right? So in other words, the current letter is a star, and if the previous letter is a star, now we know our run length has increased. So we can say that our run of stars has incremented. We also know for sure that if we are incrementing our star length, then our dash length has got to be 0. So let's reset that to, run of dashes is equal to 0. All right, so this is the case where, look, got a little typo here, need 2 equal signs. Okay, so this is the case where we're looking at stars, and the previous one was a star. What if the previous one was a dash? That means that we just switched. We were looking at dashes, and now we're looking at stars. So in that case, then our current run length of stars has got to be equal to 1 because we've just started a new thing. And maybe actually this is a better time to set our run length of dashes to 0 because we just left the dashes, in which case we don't need to reset that over here. And we need to do one other thing, which is we need to update our maximum dash score, right? We just, in this case, so this is end run of dashes. So this is a good time to check to see if our current dash run is longer than our maximum dash run. If run of dashes is greater than our maximum dashes, then let's update maximum dashes. This is actually a very common little code design. If you want to update a maximum count of something, you check to see if your current thing is greater than your maximum thing. If it is, update the maximum. And then, we don't need that pass anymore. When this whole thing is done, we want to update the previous letter to point to the current letter, because the next time around the loop, previous letter will be pointing to the one we were just at. We'll have to do the same kind of thing for dashes, but this looks like this might work for counting stars. So before we go and implement the dash version, let's try this out. Let's run this code, and what have we got? The total number of stars is 8. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. That's good. And our maximum star length is 0. Yeah, well, that's not right. It should have been 4. So we've got a bug. And this code's kind of tricky. So how do we fix this? Well, let's take a break, think for a minute, and we'll come back and figure out how we might go and debug this.